Hello and welcome to Junkyard Studios. This is a special episode because our subject is a 1950s record lathe, and it's taken me many years to acquire it, to get it semi-functional, and to the point that it's at now. A lot of musicians I speak to over the years, everybody is interested in putting their music onto vinyl. I certainly was. I thought about it probably in my first bands and kind of forgot about it for 15 or 20 years because there's not a whole lot of information. I had met an acquaintance, and we had gone to pick up a reel-to-reel tape machine, and we were at I'd say a gear collector. He had a lot of interesting pieces. He was mostly running like a museum type of a thing, and at the end of the trip, he asked us if there was anything else we needed, because he collected a lot. He had a lot of stuff. And I kind of fired off, just jokingly, "Yeah, we'll take a record lathe if you have it." And he said, "I have two." So naturally our jaws dropped and hit the floor, and this was one of them. This particular record lathe has a pretty interesting history. It was originally owned by Ewing Nunn, and he ran Audiophile Records. This is his cutter head and his lathe from that time. I've done a lot of modifications to it to kind of bring it up to something of a standard that we would expect to see today. With that, you run into a lot of complications because the AC motors that run this platter, that's our first issue. That's our first problem. AC motors, as you know, the AC signal tends to the waveform moves around. That's why it's AC. This is not original. This is just something I put here because the panel's gone. I'm still kind of working on it. You're probably going to see me struggle with it here for a little bit. Anyway, AC motors run off of alternating current. Well, that alternating current creates fluctuations in the speed of those motors, and the fluctuations in the speed of those motors, here's one of them. I know it's dark and you can't really see very well. The fluctuation in those motors throws the speed of the actual platter off, and I'm gonna try and film that for you. I have an RPM counter on my phone. I'm gonna try and film that with another phone because all I currently have is a phone. I don't have a professional camera. I just started doing this video stuff. Maybe when things get back to normal, I'll get like a GoPro or something. I haven't 100% figured out what to do with that problem, and it's noticeable when you play a mono record on this turntable. It has kind of a flange sound to it, like in the traditional sense, like actually pressing up on the reel-to-reel and reel flange and giving it an effect, which is cool to hear but not useful. So that's one of our problems. Another one of our problems is the chip suction. When I attempt a cut, the swarf is what's taken out of the vinyl material, and it goes into this suction tube. There's a rubber tube around here somewhere I gotta put back that goes down to a glass jar and collects it, because it's pretty flammable. So we don't want it just flying around or Some people wrap it around the spindle, and I guess I could do that, but I'd like to get the system going. It seems to clog right at the tube at the record head, and I haven't figured out why. I don't know what's going wrong with that. So that's something we have to investigate. Another thing, this center puck here, this is a vacuum platter. The Presto 8DG never came with a vacuum platter. This was customized by Ewing. From what I understand, Ewing had a whole lot of fabricators that he would go to, and you can see this phenolic piece here, that's not original. And this cork pad, some models came with a cork pad, some did not. This particular one, he made an air chamber in the phenolic, put the cork pad over the top, secured the phenolic underneath here with platter screws, and created a puck for the air. Because what a vacuum platter does is it sucks the lacquer down to the platter. It gives you a flatter cutting surface, so you get a better cut. Well, he never finished it. This platter, I don't know if I have any photos of it. This platter was just, or this center puck was just stuck there, and you could pull the thing out without this plate in place. So I fabricated a cover plate for it. I dug out some of the cork. Someday I'm going to have to get this probably recorked anyways. And I put attachment screws and holes there with a rubber, like a rubber gasket in there to lessen the loss of air suction, because the first test runs proved to me that it was losing a lot of air and it was basically doing nothing because it was just open. There wasn't anything holding it. That worked out pretty well. I think there's still some losses. There's some things we got to look at. Another thing that I had to do, I had to repair the microscope. When I found it, all of this was broken and the rubber had rotted, and this also didn't have any sort of a playback arm. You need a playback arm to play while you're cutting, so you can tell how your cut is going. So I created this plate to hold the playback arm, and because of the modifications to this lathe, this overhead arm was pushed back far enough where I could fit this plate on here pretty good. It's not an ideal space. I would have preferred to have it maybe over here off to the side, and that might have worked, but that microscope would get in the way a lot. So this is kind of where it ended up, and it's just what it is. There's not a whole lot I can do. This particular record cutting head was not made for this lathe. This lathe was made to handle smaller cutter heads, which I have one, and I was playing with it before I got this head back. This is actually the size that's meant to be there, but again, because of the modifications, this overhead arm was moved back probably 2 to 3 inches, as far back into the plinth as it could go. So when I mounted this head, it was off center to the spindle. That's not good for record cutting. You're gonna cut weird circles and possibly damage your record cutter. So what I had to do, create a plate this is sitting on that would push it out towards the center of the spindle. which it's done, and it was working. It probably needs a little more fine tuning, but it worked. I was actually getting better groove cuts on this than I was with the head it came with. So here's the inside of that center puck area. This was just free floating in there, so there was air all the way around that could escape. One of my other design problems that I'm having is these little holes in the puck have to line up with the holes in the platter, and there's no way you're going to be able to see that when the cover goes back on. So here is my little rubber platter mat here, and that's going to create a good seal for us. And then this will go back on top. This is our finished product. The screws are sitting pretty well. I didn't like that they were resting in the phenolic. That's how they're attached to this platter. I wanted to go through the aluminum because I think I have plenty of aluminum to be able to thread and then put in a little longer screws. But it's not going anywhere, and it's working pretty good. As you can see, that lacquer's pretty flat. That's not a lacquer, that's a CDR. You can cut into CDRs just as well. It's a different setup with the stylus, and it's a different process, but there's been multiple folks on Lathe Trolls, which I'd like to thank for all their help, and it's pretty much the only forum you can go to for help with this kind of a thing. There's not a whole lot of places. Like I said, information is very scarce, but there's been a lot of people on that forum that have done lathe cuts with these DVRs for multiple different people. That's looking pretty good. I'm gonna probably call that done. That's the last thing I was working on before I kind of gave this a rest for a little bit. Another thing I've been doing, this is going to be my button panel. I'm kind of modeling it after a Neumann, which if you know anything about Neumann, for us mere mortals, we'll probably never see one. They are the top of the line for record lathes. In the record lathe industry, not a whole lot of new stuff has been created yet. There's been a lot of talk and things floating around, and a lot of good attempts so far, but I haven't really been aware of too many readily available things. So all the equipment that we have to cut records is still from the 50s and needs to be updated. But Neumann and Scully were the top of the line. And if you want to purchase one of those, you might have to mortgage your home. So I wanted to have all of my functions up front and accessible. I haven't finished this yet. There's a lot that needs to go into it. I do have a working vacuum and a temporary setup for the lines per inch motor that moves the cutter head at different speeds, so you can get the lead in, the cut distance, and then the lead out. I'm still kind of tweaking that and getting that set. Down here we have the vacuum. This did not come with a vacuum system. This vacuum system that I have here, it's been through many revisions. I had to build this. What I started with was just a little rack case with a rack panel that had a door in it that, again, I found. I started with one vacuum motor that didn't work out so hot. it was damaged and I repaired it, and I think that was part of the issue. It wasn't giving me the kind of power I needed, and it was overheating. I even had a fan system right there. You can control the fan speed with that, and this is a temperature gauge. Even with all of that protection behind it, it's still overheated, and it would only run for about a half hour before it started getting up into like 110 degrees. I wasn't very comfortable with that. Right here is the power transformer. We had to rig that for a step-down sort of a thing, again with some help from the lathe trolls. Thank you very much. The fan, you can see the fans in there. That wiring needs to be cleaned up at some point, but this is custom from day one. So it like all of my builds, it just progresses as it goes. We get a lot better suction out of this, and it's probably close to its final stages. Right here you can see that rubber plug hanging in the Lexan right there. That's my temperature gauge, and that's in the casing for the motor. The motor is encased in a old computer plastic case. That computer was garbage, so I'm glad it could live on as a vacuum housing. Here's a better view of these motors. They're just regular old Bodines from back in the day. When I first got this lathe, I had to replace all of these rubber pieces. It was improperly stored, and they were deteriorated, and they were causing issues. So those were replaced. It took me a while to locate the correct ones, but I got it. Over here is the LPI motor setup, and I had to do some rigging, as you can see. I had to build an arm to come out off of the metal frame and get right next to the overhead spindle there. And I needed a DC motor again for that, because the DC was quieter, it was more controllable. As you saw with the scanner video, those AC motors, they're not very precise. And with this DC motor setup, it's a lot more precise, it's a lot more reliable. I started out with a couple different motors, and I actually have replaceable plates that I can use, which is why you see those wing nuts on there. That's so I can drop that plate and try a different motor. With all my builds, I try to make things as modular as possible so that I can change things out when they don't work without too much of pain. I have everything powered on right now. One of the things I need to eliminate is I have two UPSs running this lathe, and I need to eliminate that down to one. And it could be done probably over here with this custom rack gear I had to have built for me, because I build a lot of things. I know enough to be semi-competent, but as far as record lathes and associated equipment with them, I'm just not there yet. I had to pay the man, and that's okay. I'm all right with having other people work on my stuff sometimes. On that note, though, this is the device that stopped me from floating money for projects, and I'll tell you why. Because I've spent many years hunting down different pieces of gear that I wanted to play with, and I've floated a lot of money, and I've taken a lot of chances. And when you get into the record lathe stuff, it's a whole new ball game. You're taking a whole different chance. there's so few people that are doing it, and there's so few places you can go. You're really on your own with this, and it's scary, and you really need to take your precautions. So after my experiences with this record lathe, I'm done with hunting the rare stuff and floating the money and having trust in random people that they're going to come through on their stuff. And if you're going to get into this kind of a thing, that would be the first advice I'd have for you, is be very careful, be on guard, be aware of who you're dealing with, do your homework, do your research. It's even more risky than regular musical instrument purchases online or with people. It's a whole nother ball game. You're going to be dealing with a whole nother league of different things. It's not saying that there aren't reputable people out there and there's not people that you can trust. There are. The problem is there's only a handful. There's not a whole lot of people into this, so you got to be aware. Outside of that, here's my microscope. As you can see, I got the light functioning. It's pretty bright. I don't have a vinyl on here to show you. Maybe I can give you a little preview of that later. That'll show you your lines and how your cutter head's working with cutting the record. This record lathe weighs about 300-400 pounds with all the crap on it, and I had to disassemble it each time I had to move it, and I've had to move it 3 or 4 times now. So one of the times that I moved it, the way they had the power for this microscope underneath there was just a 6.3 volt filament transformer to power that bulb. But it was just bare wire straight through the deck down to the incoming 120. Well, after about the second or third time of moving it, I pulled that wire right out of that transformer, unfortunately, and I was able to repair it. But in order to avoid that mistake again, see if we can get you in there, I had to build a removable plate. You can't really see a whole lot of it, but I had to build a removable plate where I could disconnect all the power connections and take that plate off so that plinth can move without damaging all the work that I've done to that microscope. And that was one of the first modifications I had to do. One of the things, especially if you're going to be new getting into this, is this is engineering. This is going to take everything that you've got. If you've got a lot of precision equipment and you know what you're doing, I mean, this is just going to be cake for you. If you never built any of this audio electronics or have even started doing that kind of a thing, I'd suggest you go and get some kits and play around with that for a while before you come into this. This is the most ambitious project I've had, and it's been quite a challenge. And if I was you, I would be prepared for that kind of a thing. These are our different speeds. 33, 45, 78. This one does all three. Not very well, but it does it. I believe that these little protective switches here, protective switch covers, were built by Ewing so that something didn't get triggered on accident. They're a nice welcome addition, because every other 8DG I've seen, or 8GV, the V meaning vacuum plate, it's basically the same model. It just has a vacuum plate like my 8DG does. Each one had a flat switch panel without these protective devices on them. I enjoy them. I think it's a good idea. I don't know that you really need to go through all that trouble, but it's nice to have. Here's 33. It looks right. Here's 45. All of the speeds look right, and they can look right. Here's 78. That noise is probably one of my cables in the way. Usually that noise isn't there. I've had to disassemble this a couple of times working on the vacuum. All of those speeds can look right, but when you actually get an RPM counter on the platter and you check it, it fluctuates too much for precision audio work. And that goes back to the motors. And that's a problem that I was aware of in the beginning stages that I'd read about, and I thought, well, maybe my unit is different. Maybe mine's okay. No. I've come to that exact same conclusion, and something needs to be done, which I'm imagining would be DC motors and DC motor control. And that's going to be a big undertaking. I'm not sure how that's going to go. I'm still kind of researching that. You can be certain that it'll end up in one of these videos. This is probably going to be a 2 or 3 part video because this is a lot of information to cover. This is a big topic. Over here behind my button panel, I built this little makeshift shelf out of some scrap aluminum I had around. These are just prototypes for different things that I'm working on, but the main part, this is the LPI motor power supply. This is the power supply for the whole unit. I've basically been branching off each one of these devices from this power supply unit so that I can have one central location where 120 goes and then steps down to each of these devices. So the LPI motor hasn't been placed 100%, and I'm going to probably do that soon because I'm pretty happy with this setup. First thing you need to check is that the finger is down for the cutter head, otherwise it won't ride the groove and your LPI motor won't do anything. Here's our LPI motor on. Ramp it up to full speed. This is forward. I don't know that I know enough about record cutting at this point to be able to tell you that that's fast enough, but I almost imagine that it is. That actually is in reverse. That's another thing that I have to work on, is being able to switch from forward to reverse. You want to be able to do both. I'll show you how you do that right now. Let's turn the LPI motor off for you. Because I haven't found a better way of doing this yet. The original Presto way was this little coupler here. In order to go forward, you would push this coupler forward and lock it into place. Now you've changed the direction of the LPI motor. Now we'll be going forward instead of reverse. I haven't done any hard calculations as to how fast that is, but if you look at the grooves on a record, other than the final groove, the run out, which is pretty spaced out, the actual land cutting, I'm probably not using the correct terms, but the actual land in the inner disc, that's probably pretty fast for that. Either way, I feel I could put this in more permanent if something doesn't work out where that needs to be faster or something along those lines and need to change that out, I can probably pretty easily just reuse whatever I'm going to cut into this panel with a new supply. Here's my vacuum panel. It's saying that it's currently 60.2 degrees in there. Each one of these is a fan speed. I have 4 fans, so I can control each one of them. And I have everything routed back to my vacuum button. So when I'm ready to cut, which I don't have my vacuum line up to the tube just yet. Well, actually, it's back. I think it's back here. I don't have a good way of securing it when it's not in use. So there's my vacuum tube. And that's just gonna kind of slip over the top of that tube there. Before you start cutting, you'd put some baby powder through, or talcum powder through each of these, just so that your swarf doesn't get stuck, because it's it's not plastic, but it's hot lacquer, which is kind of the consistency of plastic almost going through rubber tubing. You got a good chance of getting stuck. The talcum powder allows the swarf to move better. You can hear we got suction there, and it should be coming through these holes. I've actually tested that with the talc powder. It will go into platter holes. I've also built a heat lamp. This is made from just a regular construction light, and we ran it through some conduit, some probably looks like 1/2 inch conduit, down to a spare microphone base that I had hanging around. And what this does is, this is a heat lamp. You see them in hospitals, old hospital equipment sometimes. It's going to heat up the lacquer as it's spinning and assist with cutting the groove. There's been some talk about it not being necessary if you have a heated stylus, which I do on this particular head. But the way I'm going to play around with it anyway. I wanted to build it because I figure the more help and assistance I can get, the better. What I plan on doing, and I've tried it already, is I put the lacquer onto the platter. I get it going at its speed, and I let it sit under the lamp for about 10 or 15 minutes. And then I attempt to cut, kind of try to soften that lacquer. The lacquer I have is not new, it's old. So I think that there's actually some tricks that I need to do to it on top of that because it's old. I haven't bought any new lacquer just yet because I don't 100% know how this is going to cut. I've done some tests. I've gotten close. I'm just not there yet. When we start getting some really powerful results, I'll go out and get some new lacquer and start with some fresh product. This is my test lacquer that I've been using. Those inner grooves there that you see the aluminum plating underneath the lacquer, and that outer groove there, this was purchased with those grooves there. I did not do that. What you're seeing there is somebody set their cutter depth too low, and they started cutting into the aluminum base of this lacquer, and they probably ruined their diamond or their stylus. Out here, what you see, not the aluminum stripe, those cuts are my grooves. Those are my test grooves. That first band on the outer edge, that was with the smaller cutter head. And that second band in there was, I think that was also with the other cutter head. I started a third band. You can barely see it because I'm not getting the results I wanted to. This lacquer is also kind of warped. Yeah, you can see that third band in there. It's not the best. That lacquer is kind of warped, so it's not cutting so well. And the vacuum platter isn't able to save it, so I think that warp is pretty nasty. But I got this really cheap, and the other side needs a cleaning. I shouldn't be handling this with bare hands, by the way. You should be wearing anti-static gloves, but this is just a test lacquer. So that's part one, this kind of the introduction to the record lathe. In part two, we're gonna get into how it sounds currently and some more modifications, and kind of go over the things that I need it to do and how I'm going to get it to do that. I'm going to post more photos on the blog, which I'm going to link into the description of this video, so please check that out. Also, I mentioned lathe trolls. If you're into this kind of a thing, I highly suggest that you go over there and set up an account and support them. They're a very good resource. If you find them useful, please certainly donate to them. Currently, I believe they're having some trouble. Certainly, if you enjoy this video and you want to see more of the videos that I produce, like, share, and subscribe. I appreciate it very much, and I like to bring this information to the forefront and show people the things they can do, and how, minimal investment. This particular project is not a minimal investment project, but it's very interesting. It's a subject that I talk about on a regular basis with a lot of my musician friends and a lot of different lathe friends, and I thought I'd bring it to YouTube for you. A lot of this information that I've gathered came from lathe trolls, so that's another reason I suggest going over there. There are much more knowledgeable people than myself over there that will be able to answer any question that you have, and pretty much anything that I've put in this video I probably got from that website. So definitely head over there, take a look at it, like, share, and subscribe if you enjoy my videos, and watch out for part two, where we're going to get a little more in depth with this. Thanks for watching.